Am I audible? Please acknowledge in the chat box so that we can start the session. Is my voice clear? Thanks. Yeah. So let us start this session. So from this session, we are going to discuss about Boolean algebra, Boolean laws, and we are going to start discussion about this. So yeah. So let me share my screen. About this Boolean algebra. Okay. So basically, this Boolean algebra, if I want to simply say, this Boolean algebra is nothing but mathematics of logic. Okay, I'll write down here. So Boolean algebra is mathematics of logic. Okay, like how we have your algebra in your maths. So same like this, we are going to have this particular Boolean algebra, and it is the most basic tool which is used for analysis and synthesis of the logic circuit. And we already know in Boolean algebra we are going to have the variables, like we are going to use a, b, or x, y, z. Okay, so this type of variables we are going to use in this Boolean algebra. Okay, now so in this Boolean algebra we are going to let's see what are the logic levels which we have. Okay, so let me write down here. So we have different type of logic levels which we have in this Boolean algebra. Okay. So the Boolean logic variable 0 or 1 is not used to represent the actual numbers. Okay. So if you have any value as 0, or if it is 1, so it is not the actual value. It is not a decimal number, but it is representing the state of the voltage variable. Okay. So this is nothing but your logic levels or voltage levels. Okay, so basically these are representing your voltage levels. Okay, so for example, if we have a logic 0 or simply 0, that means what we are representing, it is nothing but a low voltage, or you can also say it is an open switch. Or if you have a logic 1 or simply a1, this you are representing it with a closed switch. So this is the analogy which we can relate it with. Okay, and sometimes this logic low is also for your false condition, and logic 1 is also for your high condition. Okay, or true condition also you can say. Okay, so these are the logic levels which we are going to use a lot in our Boolean algebra. Now, and we have one more terminology. I hope you're already aware of this. The term is truth table. So what do you mean by truth table? What it is basically describing, the truth table? I know it's a simple basic question, but just to confirm, what do you mean by truth table? So basically, this truth table is establishing it is basically establishing relation between your input and output. Okay, so the truth table is basically defining the relationship between the input and output. Okay, so it is like a table which is having some set of inputs on the left hand side, and it is having some set of outputs on the right hand side. Okay, so this is nothing but your truth table. Okay, now let us see your basic logic operations which we are going to deal with. So let me write down them. Basic Boolean operations. So we have different type of Boolean operations which we are going to see. So first one is OR operations, and second one is AND operations, and followed by not operations. So these are the basic operations which we are going to have in the Boolean algebra. One is or, and you can also say not. Okay. So this or operation is also known as your Boolean addition. So this or operation is also known as your Boolean addition, or you can say it as logical or. And this and operation is also known as your Boolean and, or Boolean multiplication also you can say. And it is also known as logical and. And coming to this last one, this not operation, it is also known as your logical not operation. Okay. So for example, if we have a, so let's say if we let me change the color. So let's say if we have this logical or operation, so we are going to represent it with the plus symbol, and this logical and operation is represented with dot symbol, and this not can be represented with a bar. So logical not is represented with the bar on the variable. Okay. So I think this we already know. Okay. And let's see one example for a logical or operation for a two variable. Let's say if you have two variables a and b, and you have y. So how many possible combinations are there for two variables? So total 4 exactly. 0 0, 0 1, 1 0, and 1 1. Okay. So quickly tell me all the results, the values of y. What are the outputs in this case? Quick, the chat box. 0001, 0 So it's actually 0 Okay. So we are performing logical OR operation now. So it is nothing but your 0 Okay. So 0 OR with 0 is 0, 0 OR with 1 is 1, 1 OR with 0 is 1, and 1 OR with 1 is 1. Okay. So some people will do 1 OR with 1 is 0. It is not addition, it is Boolean addition. So that's why I'm stressing on this particular point. This is Boolean addition. What we are doing is Boolean addition and logical OR operation, or it is also a logical OR operation. It is not your normal addition. So in the normal addition, if you are adding this 2, you will get your sum as 0 and carry as 1. That is different. This is logical OR operation. Okay, so please be careful in this one. Okay, yes. And in the case of logical AND operation, we know. So if we have this particular time 0 0 0 1 1 0 1 1, so we will simply get 0 0 0 and 1. And simply, and if we have, this is your logical AND operation. So this is your logical AND operation. And if we have your logical NOT operation, like let's say suppose if your a is equal to 0 and the logical NOT operation of a bar is 1, and if you have a is equal to 1, then your logical NOT operation of a bar is equal to 1 0. Okay, so this is your logical NOT operation that we already know. Okay, is this clear for everyone? Any doubts in this? I hope there is no doubts in this, right? Yes. Now, so let us see some theorems in Boolean algebra. Okay. So why we are learning these theorems? Anyone have any idea, like why we need to learn these theorems? Why we are learning these theorems? Exactly, for minimizing the Boolean expressions. So we are learning these theorems for minimizing the Boolean expressions. Okay. So we have different types of theorems in the Boolean algebra. So first one, I'm going to discuss only the important ones. Okay. So the first one is complementation laws. No need to remember any name of this. Just remember the concept. Okay. Complementation laws. So first type of theorem is known as complementation laws. So what are these complementation laws actually saying is, So this complementation laws, we have different type of complementation laws. Let us see one by one. So first complementation law is null law. No need to remember any name here. Okay, just for your reference I'm giving the names. Okay, so null law is nothing but if we have a variable and if we perform AND operation with 0, that is nothing but a dot 0 is nothing but 0. And we have one more law is identity law. So this law says that if we multiply any variable with 1, or if we perform logical add or logical multiplication, then the resultant is a. Okay, not 1. So many people will write 1. It is not 1, it is a. Okay, and we have one more law which is known as mm, so complement. Yeah, so sorry, this is not complementation laws, this is add laws. Okay, so what I'm writing is add laws. Okay, and if we multiply your a and a, and if we multiply your a and a bar, so what is the result we are getting here and what is the result we are getting here? Can anyone tell me what is the result? A dot a. Exactly, a. And what is a dot a bar? It is 0. Okay, exactly correct. Okay, so these are nothing but your and laws. Now next is complementation laws. Now, what do you mean by complementation laws? So, in the complementation laws, we have, like, let's say, suppose if you have a variable a which is equal to 0, then a bar is equal to 1. This is obvious, okay? And if you have a is equal to 1, then obviously a bar is equal to 0. Okay, this we already know. Now, let's say if we have a variable a is equal to 0, then what is a double bar? Double complementation of a. It is nothing but it is equal to 0. That is a double bar is also equal to a. Okay, so this is your complementation laws. Now let's see your another type of laws, which is nothing but or laws. So in the case of or laws, we have your again null law, identity law. I'm not writing those names, so just we will see a plus 0, a plus 1, a plus a, and a plus a bar. Why I am discussing from this basics is, so if anyone is not confident in this particular terms, please be confident in these terms. Okay, please be aware of all these operations. Now can anyone tell me what are those values? What are the four answers? Quick, in the chat box. A1, a1. Okay, what about others? Okay, so basically a plus 0 is nothing but a, and a plus 1 is 1, and a plus a is a, and a plus a bar is nothing but 1. Okay, not only a, you can take any variable. If you are performing logical or operation with 0, you are going to get a, and if you are performing logical or operation with 1, you are going to get 1, and if you are performing logical or operation between the same variables, you are going to get a, and if you are performing logical or operation between the variable and its complement, you are going to get 1. Okay, so this is nothing but your or laws. Now, so we have another type of law which is known as commutative law. This is also, it's a simple law only. No need to remember any names. Now, so this commutative law says that if we have a two variables, then if you perform a plus b, then you can reverse the order. That is b plus a. And if you perform a dot b, then you can reverse this positions b dot a. Okay. Then the resultant will be same. Now, so we have one more type of law which is known as associative law. So this associative law says that if you have this type of variables, let's say let's take three variables a plus b plus c, then this is equivalent to a plus b plus c, and if we have a dot b dot c, then it is equal to a dot b dot c. Okay, so this is nothing but your associative law. These two values will be equal. And one more law which you have is your distributive law. So in this distributive law, again we will take three variables, m plus n plus c. So this can be written as, sorry, m dot n plus c. M dot n plus c can be written as mn plus mc. Okay, and let's say suppose if we have m plus nc. So what can we write this particular thing? M plus nc can be written as, anyone knows? M plus nc can be written as, this m plus nc can be written as, anyone knows the answer? Exactly. So this can be written as m plus n into m plus c. Exactly. Okay. So this is your distributive law. This is very important. This we are going to use it in our problem solvings. Okay. So from this distributive law only, there will be using this particular formula, using this particular rule, we are going to have one more law, that is nothing but redundant literal rule. So no need to remember that particular name. So I will give you the particular example for this. Like let's say suppose if we have a plus a bar b. Okay. So what can be written as? So you can apply the distributive law here. So that is nothing but a plus a bar into a plus b. Now what is a plus a bar? Whether it is 1 or whether it is 0, or whether it is a or whether it is a bar. Exactly. A plus a bar 0, no? What about others? What is a plus a bar? What we have seen? Okay, yeah. So then that is why I've discussed all these laws. So we will get confused in sometimes. Okay, no issue in that. So this is nothing but it is 1 into a plus b. So this is nothing but redundant literal rule. So no need to remember any name for this. Okay. Now, so let's say if we have a into uh, if we have a into a bar plus b, a into a bar plus b. Now what is the result for this? Can anyone tell me in the chat box what is a into a bar plus b? What we are getting? Exactly, ab. No, not 1. So see how we are solving this. So this is nothing but a dot a bar plus ab. Now what is a dot a bar? Whether it is 1 or whether it is 0. What is a dot a bar? 0. Okay. In the AND laws we have seen, right, a dot a bar is equal to 0. Okay. So that's why here it is equal to 0 and this is the leftover term. So our final answer will be equal to ab. Is that clear? Next we have one more law which is known as Idempotent Law. So what is this law saying? Like let's say suppose if we have a dot a dot a dot a so on some 100 variables or 1000 variables dot a, then what is your result you are going to get? Any guess? Any idea? A dot a dot a dot so on a. Exactly a. Exactly correct. So you will get simply a. And let's say suppose if we have a plus a plus a plus so on some 1000 2000 variables a, then what we are going to get here? A. Okay, here also we are going to get a. Okay, so this is nothing but your idempotent law. Now, so we have one more thing which is known as your absorption law. That is not necessary to describe the name, but I will show you. So a plus ab. So what is the result we are going to get here? A plus ab. So this is nothing but your absorption law. Exactly a. How we are getting a? So if we take a common here, if we take a common here, a into 1 plus b. Now what is 1 plus b here? Whether it is b or whether it is 0 or whether it is 1. Yeah, what about others? B plus 1 is, it is equal to 1. Okay, so it is nothing but 1. So 1 into A is nothing but A. So we are going to get A. So this is absorption law. And let's say suppose if we have A into A plus B, what is the result we are going to get? A into A plus B. Yes, what about this? A into A plus B. What we are going to get? Exactly. So this A into A plus B will be converted. If you multiply, you will get this only. Okay. That is nothing but A plus AB. That is further simplified into A. Okay. So this is nothing but your absorption law. Yes. Now, the very famous theorem, which is known as your DeMorgan's theorem. So what is DeMorgan's theorem stating? So A plus B whole bar can be written as A bar dot B bar, and AB the whole bar can be written as A bar plus B bar. Okay. So this is nothing but your De Morgan's theorem. Okay. So this is very important. Yeah. So up to here, is it clear for everyone? Any doubts and any queries up to here? All clear? Shall we move forward? Yes. Now we have to understand one more important point here is logic levels. So let us try to understand this logic levels. So what are these logic levels? How they are going to be used? Okay. So this logic levels are divided into two types. Okay. So we have two type of logic levels. One is positive level and second one is negative level. So we have two type of logic levels we have. One is positive level and another is negative level. Okay. So what do you mean by positive level? Let us try to understand what do you mean by positive level here. So let's say if we have a transition from 0 to 1. So let's say this is our voltage level. Okay. So this is logical 0, and so let's say this is 0 volt. Okay. This particular, it is 0 volt and this is 5 volt. Okay. Now, uh, okay, I will draw here. So let's say, let us first consider your positive level. Positive level. This is very important to understand. So let's say if we have a waveform like this, okay. So this is corresponding to 0 volts and this is corresponding to 5 volts. Okay. Now, in the case of positive level, you are representing your higher voltage. You are representing your higher voltage with logic 1. You are representing your higher voltage with logic 1 and you are representing with lower voltage with your logic 0. Yes, is it clear? So you are representing your higher voltage with logic 1 and you are representing with your lower voltage with logic 0. Okay, so this is nothing but your positive level. Now, next in the negative level, in the case of your negative level, let's say if we have our same waveform like this, so this is our waveform and this is your 0 volt and this is your 5 volt. Now, you are representing your lower voltage. You are representing your lower voltage with logic 1. You are representing with your lower voltage with logic 1 and you are representing with your higher voltage with logic 0. So this is nothing but your negative level. So this is the difference between your positive level and negative level. Is this clear for everyone? Any doubts or any queries in this? So the positive level and the negative level, is it clear? Yes, exactly. Okay. Now, So let's say if we have a question like this, like let's say suppose if uh, we have to represent your voltages in negative level. We have to represent your voltages in negative level, and okay, like let's say suppose if we have minus 5 volts, what is the logic level you are going to give it this, and minus 10 volts. Can anyone tell me what is minus 5 volts is represented by, and what is minus 10 volts is represented by in the negative level? Minus 5 volts and minus 10 volts. Okay, first of all, tell me which is greater, minus 5 or minus 10, which is the greater value in these two values, which is greater value, minus 5 or minus 10? Minus 5. Okay, so what we have seen in our previous discussion, that greater values are represented with logic 0, and lower values are represented with logic 1. Okay, so what is the lower value here? Minus 10 is a lower value, so this is given as logic 1, and this is being represented with logic 0. Okay, so this is how you are going to decide which logic level we should be using for representing these values in the negative level. Okay, now is this clear for everyone? Exactly, minus 5 logic 0 and minus 10 logic 1. Exactly. Now if we want to represent the same thing in the positive level, if we want to represent the same thing in the positive level, so what will be the logic levels? Reverse. So if we want to represent minus 5 volts and minus 10 volts, then this will be represented with logical 1, and this will be represented with logical 0. So up to here, is it clear? Yes or no? Anyone having any doubt in this, please let me know in the chat box. And please don't keep your doubts with you. Please let me know so that I will solve it. And if you have any small doubt also, please don't hesitate. No one knows you here, okay? And no one will judge you, okay? So if you have any small doubt also, you can ask me, okay? Yes. Now, so using this concept, let us conclude one important point here. So let's say if we have a AND gate or AND operation, if we want to perform between the two variables, okay, we have a function of a comma b, that is we are going to have two variables a, b, y. Okay, now I want to write the truth table for this AND operation in the logic high. Okay, I want to write down the uh, truth table of this AND gate in the positive logic, in the positive logic. How to write this? Positive logic is already we know. So 0 0 0 1 1 0 1 1. Here 0 is standing for 0 volts, let's assume, and 1 is standing for, let's say, 5 volts. Okay. Now that means we are going to get 0 0 0 1. This we already know. Now let us try to write down the AND gate for your negative logic. That means negative logic. That means you are going to represent your 0 volts. You are going to represent your 0 volts with logic 1 and 5 volts with logic 0. Okay, that is high voltage you are representing with logic 0, and low voltage you are representing with logic 1. That is the difference. Okay, so let's say if you have the function variables a, b, and y, can anyone fill this table for me? 0 0 0 1 1 0 1 1. What are your outputs? Exactly. Okay, exactly. So 0 0. So 0 0. This is high voltage. Okay, 0 0 means high voltage. because your logic 0 is representing your high voltage. So output also you are going to get a high voltage. So how to represent your high voltage? You are going to represent your high voltage with 0 or 1. You are going to represent your high voltage with 0 or 1. So this is 0. This 0 is representing your high voltage, and this is 0. This 0 is representing your high voltage. So what it is going to have? Is it 1 or is it 0? Please tell me in the chat box. Yes, guys, I'm waiting for your response. This is 0. Okay. And this is 0. This 0 is nothing but your high voltage, and this 0 is nothing but your high voltage. If you are going to apply high voltages to an AND gate, so what is your output? You are going to get a high only. Am I right or wrong? Yes or no? Now, what is this high? You are going to represent it with either 0 or either 1. You are going to represent this with 0 now. Okay now? So you are going to get 0 here. Is this clear? Is this clear for everyone? Yes, no in the chat box, please. Yeah. And what you're going to get here, this is high voltage and this is low voltage. Obviously, you're going to get your low voltage. Okay. So how you are going to represent your low voltage with 1, and this is also 1, and this is low voltage, that is 1. Okay now? 0 triple 1. Is this clear? I think someone has given 0 triple 1 triple 1 0. Okay, you have given reverse. Okay, so we will get 0 triple 1. So are these two clear? The AND gate truth table for the positive level and the AND gate truth table for the negative level, negative logic. Is it clear or not? Yes or no? Please let me know in the chat box. Anyone needs the explanation again in this one? Yes? No? Needs explanation, or shall we move forward? Please let me know in the chat box. Others? Okay, so let me explain you one more time. So this is 0, this is 0. Okay, what is 0 representing it here? 0 is representing your high voltage. Okay, so you are applying high voltage across your AND gate. On the two terminals, you are applying high voltage. So what is your output? You are going to obviously get your high voltage. Now, how you are going to represent this high voltage with which logic level you are going to represent it with? You are representing this high voltage with 0. Okay, so that's why what I have written here 0. Okay, now high voltage, low voltage, obviously. So this is your AND gate. Here you are applying high voltage and here you are applying low voltage. Okay, high voltage is 0, logic 0, and low voltage is nothing but logic 1. Okay, because this is negative logic now, obviously you are going to get your low voltage here. Okay, now how you are going to represent your low voltage with? You are representing your low voltage with 1. Okay, so that's why you are getting 1 here, and for the remaining cases also you are going to get 1. Now is it clear for everyone? Okay now, so this is how we are going to write down your answer. Now can anyone tell me, have you seen this particular truth table anywhere before? Is this truth table familiar? Is this truth table, have you seen this truth table anywhere before? Where? What is the gate? What is this truth table corresponding to which gate it is? See again, see the truth table again, and can anyone tell me for which gate we will get this exact truth table? NAND gate? No, no, no. NAND gate, it is no, no. NAND gate, it is 1110. Exactly. OR gate. Okay. This is the truth table for your OR gate in the positive logic. Okay, so let me write down the truth table for your OR gate in the positive logic and let me show you. So if you have a OR gate, I'm writing this in the positive logic. So what is positive logic here? Positive logic is nothing but low voltage, that is 0, you are representing with logic 0, and high voltage, that is 5 volts, you are representing it with logic 1. Okay, so if you have your inputs A and B and your output Y, 0 0 0 1 1 0 1 1. So what is your output? 0 1 1 1. So this is your OR gate truth table for positive logic. Okay. And have you seen this gate? Have you seen this? Yes. In the negative logic of your AND gate, we are getting this particular table. Okay now. So can I conclude that? Can I conclude that negative logic AND is equivalent to positive logic OR? Can I come to this particular conclusion? Yes, no in the chat box. Because the truth tables we can see same, right? The truth tables are same only, right? Yes or no in the chat box, please. Yes. Okay. Now let us see one more last one, that is OR gate in the negative logic. Why I'm explaining this everything? Because we need to understand one more important concept, that for that I am explaining these things A, B, Y. Now, here in the case of negative logic, 0 volts I am representing with logic 1 and 5 volts I am representing it with logic 0. Okay, so 0 0 0 1 1 0 1 1. Quickly tell me the answers for this, or slowly tell me the answers for this. Exactly. I'm going to conclude that particular point only. So using one thing, I'm going to conclude that particular point. Yeah. Now quickly fill up this particular table. Triple 1 0. Okay, let's see. So if you have a OR gate like this, so draw an OR gate. Okay. Now 0 stands for your high voltage. Okay. And again you are applying high voltage. High voltage. If you are applying, you are going to get a high voltage, and you are representing your high voltage with logic 0. Okay. This is your logic 0. So you are going to get logic 0. And this is high voltage, and this is low voltage. This is high voltage, and this is high voltage. You are going to get a high voltage only. Okay. And high voltage or with a low voltage, you're again going to get a high voltage. How you are going to represent your high voltage? Again, it is going to be represented with logic 0. Okay, so 0. This is high voltage, and here also you're going to get a high voltage, and here this is low voltage, and this is low voltage. Okay, that means if you are going to apply 0 volt and 0 volt across your OR gate, then you are going to get a 0 volt. And how you are going to represent your 0 volt? With logic 1. So this is nothing but low voltage. Is this clear for everyone? The OR gate, is it clear? The negative logic OR gate, is it clear? Exactly, Selva. Yeah. That means negative logic OR gate is nothing but it is equivalent to your positive logic AND gate. Am I right or wrong? Yes or no? Yes. Now, has anyone studied about dual of a function? Dual. Have you seen this particular thing? Dual of a function. Yes. So let's take an AND gate. Let's take an AND gate in positive logic. Let's take an AND gate in the positive logic. So what is the expression for AND gate in the positive logic? So you can refer this table. So what is the expression we are getting? So if you don't know how to write the expression, Boolean expression, by seeing the truth table, don't worry, I'm writing it directly. I will explain this how to write if you are a beginner. Okay. So my output will be equal to simply y is equal to a dot b. Okay. Y is equal to a dot b. So I will fill this here. The AND gate in the positive logic, y is equal to a dot b. Now, if I want to find the dual of this function, what I am going to do? The dual of this function is, if I find the dual, then what I am going to get, y is equal to a plus b. So how I am going to find the dual? So for finding the dual, we will simply replace your dot operator with plus operator and plus operator with dot operator, and we are replacing our 0 with 1 and 1 with 0. So this is nothing but performing dual. Now, can anyone conclude me actually what we are doing? So what is dual doing actually? What it is doing? Why we are performing dual? What it is doing? From this entire discussion, what is the dual performing? From this entire discussion which we have seen, performing this dual, converting dot operator to plus operator, plus to dot, why I am discussing everything, what is dual doing? So can I say, if I perform the dual of a function, then it is nothing but it is converting your positive logic to negative logic? Am I right or no? Yes or no? It is basically converting your positive logic to negative logic. Let's say, let's see. Okay. So if we perform dual on this function, that is y is equal to a dot b, we are getting a plus b. So what is this a plus b? Have we seen a plus b anywhere? So this is nothing but your a plus b now. So if you take the minterms here, you will get y is equal to a plus b. What is this? AND gate in the negative logic. Am I right or wrong? Yes or no? Can you able to see this? So if you perform the dual of a function, that is you're converting from one logic to another logic. Okay. And let's say if you have y is equal to, if you take an OR gate, if you take an OR gate in the positive logic, then what is your expression? Y is equal to a plus b, and if you perform the dual of this function, you are going to get a dot b. So this is also your OR gate expression, but in the negative logic. This is your OR gate expression in the negative logic. Okay. So I think it's you have understood, but if you are not understanding this also, no issue. We'll discuss more in the upcoming sessions, but I've tried my level best to explain this dual of a function, why we are performing this dual of a function. We know we will perform the dual of the function, everything we know, but why we are doing this particular things, the reason for this is this. Okay. Yes. So any doubts or any queries in this particular discussions? Yes. So if anyone has any doubts or any queries in this particular discussions, you can stay and discuss with me, or else you can leave the session. Okay. Yes. Thank you.